It's Friday, 4 p.m. You cannot think of spending any more time in the office. You had a heavy week. You just want to go home. There is a beer in the fridge waiting for you. And you just cannot stand any longer the idea of being at the office. Unfortunately, somebody managed to sneak a ticket on your board, and you were kind enough to tell them you would do it. So you quickly put together this piece of code, which goes to an API, fetches a user, formats the user, and then renders that user to the screen. You already committed push to CI, and while you're waiting for the build to be green, you decide to take a last look at the code. But unfortunately, you notice that there is a big problem here. This is a TypeScript file, but the code is actually JavaScript. And you cannot call yourself a TypeScript developer if you have no types in your files, right? Okay, so you decide to fix this problem so that you can finally go home. You start there at the bottom, and you see an argument named string. Surprise, surprise, it's a string, and the return type is void because the function is performing a side effect. Up there is a user, and by looking at the body of the function, you remind yourself that that user contains a name, which is a string, and then you have a birthday, which you slice, and the first 4 characters are a year. So could be an array, but more likely it's a string, so you type it that way. The function returns a string too. And then up there is a JSON, which is passed into format, so it must be of the same type. So you type it that way. And then, of course, those two things are the same, so you can extract it into a user. Cool. Git commit, git push, and you just wait for CI to be green. You are already zipping your jacket on, tying your shoes, half a leg is outside of the door, but then you decide again to take a look at the code. And this time, there is no only one problem, there are two actually. The first one is that this fetch could fail, right? So there is no error ending here, only the happy path. Even more terrifying, the problem here. This user, given how typings are typed in TypeScript, this is actually a cast. So if the API returns something that adheres to our specifications in the types, then everything is fine. But if the API returns, for example, the birthday as a POSIX, starts returning the birthday as a POSIX, this explodes. Even more terrifying, if the API returns null, this still compiles, because of course, at compile time, TypeScript doesn't know what values are going to flow through the functions, but this explodes. Like there is no tomorrow on production. Now, maybe this is a bit controversial, but in my opinion, most of these problems are coming out from the fact that we were using static types as a refactoring tool and not as a design tool. Now, let me ask you a question, and I know the answer is yes. Have you ever wrote some code where when you're done, you are just taking a look at it again, and you realize that the code is not exactly doing what it was supposed to be doing? The code is too slow, and it looks like shit, to be honest. So you would have a hard time having somebody merge it. Well, so then you decide to refactor it, and refactor it, and refactor it, and refactor it, and refactor it again, until at some point the code gets to a place where, it works. There's an edge case, but it will never happen on production. It is kind of fast enough, like barely, but is, good enough there. And also, the shape of the code now, it's good enough that you think you could convince somebody to merge it on GitHub. Well, maybe you would have to pay for the lunch, but, that wouldn't be impossible anymore for somebody to merge it. And again, the problem here is that you cannot refactor yourself out of a bad design. As soon as you have the code written, maybe the unit tests, maybe even the PR open on GitHub, it's really difficult. You would go back and change the code, especially that you would change the design. And this is the exact same problem we're talking about here. We didn't think about the design upfront. We deferred to later, and then we didn't actually do it in the end. So I propose let's scrap everything, start from scratch, and use types as a design tool. Before we do that, a couple of words about me. I'm Ricardo. I was privileged enough to spend some time abroad, so I collected some nicknames over the time. And I have some fun collecting type level tips at typescript.tips. Don't worry, I'm not selling you anything, so you can go there and not fear any marketing nor sales. And I guess I spent a long time in dynamic languages like Ruby and JavaScript. And also, I had the privilege of working with Haskell and Elm, and some PureScript on the side, and also some on production. So I kind of had this cognitive dissonance of static types and dynamic languages. And this talk comes out from all of that pain that I kind of kept in my head for a long time. Okay, so again, let's start from scratch and rewrite the code by thinking with types, by using types as a design tool. Now, there are 3 things to do. Of course, at work, the code you write will be more difficult than this. I hope so, at least, because otherwise it would be really boring. But the idea is that, pretty much any algorithm, you can, if you have a good skill at breaking down problems, even the most complex thing, you can try to separate it in smaller steps. And also, I wanted to keep the problem simple enough so that we can focus on the process. And the process can be applied pretty much anywhere. Okay, so we need to fetch the user, format the user, render the user. There is one thing in common, which is the user, the data structure. So let's start there. Now, my favorite programmer is Mark Twain. Write code drunk, refactor sober. Or at least that's how I remember the quote. And I really like that because the idea of designing, implementing, and refactoring is that these activities are completely separated. They are actually contrasting activities. And you know that if you have ever wrote some code and then spent 30 minutes trying to give the perfect name to a variable, just to realize 5 minutes later that you didn't even need that variable. And that's because designing, implementation, and refactoring were fused together in a way that actually kind of blocked you from achieving any of the 3, actually. So we have the type user. But wait a minute, we already saw that. And the problem here is that we're always pretty much biased whenever we're writing some code, right? Because maybe there is already an API we need to consume, or maybe somebody else wrote some code, or maybe we are integrating with anything else. So we're kind of biased by somebody else's design. And the way I would approach this is, okay, even if you're biased, come up with some sort of design, and then always ask yourself, why is this a bad idea? This is a good way to unbias yourself and to find opportunities to do something better. So for example, let's ask this question and see what comes out. So for example, name, if I see this type and I read name, is it a display name, a full name, a last name? It's not really clear, right? Also, maybe we should actually have a specific type for that string. Maybe it should be a first name type, because using just string would allow us to have an empty string value there. Maybe that's not okay in our domain. So let's rename name to first name. But when it comes to the string, I would step back for a second. Now, we can have philosophical discussions about the perfect way to write code. But at the end of the day, the value we produce is by the fact that we ship working code. And it's not really important to have the perfect model of reality, especially because it's impossible. And we all know that all models are wrong. But our job is not really to try to find the perfect model, is to write the model that is useful to the domain and to the users we have. So sometimes it's difficult though, because you never know when to stop. Like, should you refine your code more or should you just stop? And the way I try to approach it is ask yourself, what happened is if that specific thing failed? We should never approach code as trying to be perfect 100% of the times. There are places in the code base where 20% of the effort is good enough, and some other places where maybe you need more. But it's important to differentiate. In this case, yes, we could be more sophisticated, but at the same time, maybe in our domain, an empty string is a totally valid thing. Or maybe this is something about a user profile that starts with an empty string. So actually, it makes sense to start to have a type that allows for an empty string. If, of course, we were in a domain where, I don't know, legal or document sort of domain, then, a document where you're supposed to have a name, but it's an empty string, maybe makes the entire document invalid. So in that case, you could be much more sophisticated with it. So for this presentation, let's leave string there. What about birthday, though? We saw that we are actually formatting a user at the beginning by only using the year. We are slicing on the string. So maybe we could just have the year there and use number as a type. Or maybe we should use a type that is birthday and specify better the semantics of that birthday. Well, in this case, let's go with the second option, because, I don't know, maybe because we know that later on we are going to have a ticket where we need to take care of month and day. Okay, so now the question is, what is birthday, though? The most reasonable thing to do here would be to have year, month, and day as components in the type. And then day and month could be numbers. But let's step back for a second. Why is this a bad idea? Well, day 1,300,052 doesn't really make sense, in our domain at least. And month minus 12 also doesn't make sense. So let's go with something better. We can type a few more characters and kind of reduce the bug surface area from infinite amount of values to much less. Of course, in this case, February doesn't have 31 days, but we went from infinite amount of days possible to 31, which is potentially better. And of course, we could be, again, more sophisticated with our types if it was really important to disallow the fact that our program can model a month February with 31 days. When it comes to year, let's say the specifications say we will need users that were born in the 20th and 21st century, and we can encode it this way in TypeScript. And then we have our type. Now, what have we learned here? The trick in working with types is to always think of type cardinality. Now, cardinality is the amount of values that you can instantiate of a specific type. In Boolean, you have true and false. The type null has cardinality 1 because you can only instantiate the value null. The type string has cardinality infinite. The trick is always to ask yourself, how can you use types to design your program so that you allow all of the valid states in your domain, but you disallow all of the invalid states? And by doing that, you remove a ton of bugs from your program. Because we all know that it's not a matter of if, it's a matter of when. If you allow an invalid value to flow in your program, at some point it will happen, right? Okay, so we have the user ready. Let's move to fetch, format, and render. Now, Fetch is the idea of exchanging a URL, which is a string, for a user. Though we actually are going to fetch that user somewhere outside of the system, so this could fail, and we could mark the failure as we type null. So whenever something goes wrong inside of the function, we represent the error by returning null. Or maybe we could think of using an error type that is more specific, so that would allow us downstream to take decisions depending on what error happened. Maybe we want to retry the request, maybe we don't want to retry the request because we know it's going to fail again and again. But let's keep it simple for now and use null here. Also, again, we're going somewhere else, and the way we represent the synchronous operations in TypeScript is by using promises. Format takes a user, returns a string. Though we know that upstream we could get an error, which is marked as null, so we need to take care of that case too here. With render, we take a string, perform a side effect, so the return type is void. So we are probably doing this work on the whiteboard because that's the best place when you need to refactor your design. You just wipe and you can start over without paying any exorbitant cost because you spent days on an implementation. And you need to make sure that your types and your algorithm actually is going to be working by making sure that the output of each function fits into the input of the subsequent one. So in this case, we took care of that perfectly. Notice that another trick you can use is, besides going from left to right, you can go from right to left and ask yourself the question, do I have all of the input to produce a value of this type as an output? And this is another good way to find edge cases and problems in your steps. Cool. So we already did all of the thinking in the design phase. Maybe we're also a bit drunk, as Mark Twain suggests. Now we need to be sober, because our job right now is that the creativity part was done in the design phase. We were maybe silly, we were exploring many ideas, and we could do that because the cost of making mistakes in the design phase is really small. You can reiterate on things super quickly. But now the implementation phase is not anymore about being silly or creative. It's about making code compile, because we have such precise types that if we make it compile, it should be good enough for our code to be correct and work properly. Of course, you may want to write some tests. I'm not saying you shouldn't, but that's another talk. Okay, so we have our fetch. We already know the type. So there is only one reasonable way of fetching in TypeScript. Now, we need to remember that we need to return user when we got a valid user from the API and null when an error happened. So for the error, we wrap everything in a try catch. And then we need to return something here. And again, this seems like we actually have a problem. We need to go back into design phase because we didn't really think about what happens here. We don't have a function for this. But it's not completely true, right? Because we already know that this function must take something from an API and return either user or null because it's in the type of fetch. So we can just give it a name, parse, and just take the type that we already have. And again, we are back into implementation mode, right? So that's easy. Let's just do it, right? So whenever the API gave us something that is not a user, we will return null. So if the API gave us null, we return null. Then we check if the API gave us an object. Then we check if the API gave us something that has a first name. Then we check if that first name is a string. Then we check if birthday is in that object. Then we check if birthday is an object, so on and so forth. Now, this looks really bad. But it doesn't look bad because it's a lot of code. The real problem here is another one. Let's say at some point in the future, we actually disallow users that were born in the 20th century. So we take that branch and we remove it. But for sure, we're going to forget about updating this branch here in the code, right? What does it mean? It means that in the code, we say that all of the users that are typed as user were born in the 21st century. But whenever the API gives us something that is a user that was born actually in the 20th century, we make it pass, and we pass it into our core logic, even if that shouldn't be a valid user. This parse function should return null when the user was born in dates that are not allowed for the type. Now, of course, the standard way of fixing this in TypeScript is to use something like Zod. If you squint enough, and please do if you don't know Zod, this code looks exactly like the types we wrote before. But instead of defining a type, this code is defining a schema. And the great thing about Zod and schemas in Zod is that you can use that schema to derive two things: our parser and the type for user. So we already fixed the problem because we have one point of truth, and whenever you change that schema, both the parser and the type are going to be updated. With the additional benefit that we don't even need to write a parser anymore, so that super long function went from this amount of code to four lines. Now, the important element here is that, I guess, don't get candies from strangers, or better said, never trust a system that is not yours. So if something happens outside of the boundary of your system, don't trust it. Always parse the values that are coming in, because if you do that, you're going to simplify your life so much. Because whatever comes to your logic, it's valid. And you can just pass it through the core of the domain, and nothing can really explode anymore because you are guaranteed that the value you got is valid. Okay, so we have our fetch. Now, let's notice that the important pieces are these ones. We can extract it into a chain as it was at the beginning in the first slide. Okay, what about format? Well, format is super easy, right? We get either user or null, so we first check if we got null. If that's the case, we return an error as a string, of course, because the return type is a string. Otherwise, we format the user. But notice, this time, we are guaranteed 100% this line cannot fail. Before it could explode, now we are guaranteed that the parser gave us something that is valid here. What about render? So render takes a string, performs a side effect. So this is pretty simple, right? And notice one important thing. Types have this sort of like, they capture the meaning of the operations we are performing. So all of these types are still valid, even if we decide to replace the implementation with something else. Like, for example, this render could be a jQuery DOM manipulation operation, which is still a side effect, so it returns void. So the type is still correct, but the implementation is different. Or it could be, React rendering, whatever, on the DOM. And finally, we are here with a new code. And compared it with the previous one, of course, it's much more code, unfortunately. So, to wrap up, we never really refactored the code. We designed into it. Yes, we did some improvements like extracting the chain of functions from fetch, but we actually started with the design in mind, and we implemented specifically that design, which was correct and proves correct. But by following the process, we actually needed to understand the domain really well. So we actually had to ask really precise questions to get really precise answers so that we could encode the domain in the types. Which means we designed something that allows all of the valid states of the domain in the code, but this allows our program to even construct invalid values in our domain, which means we slashed a ton of bugs. More importantly, you actually have this domain autocomplete right now in your IDE, because a few weeks from now, since you have so precise static types, you will just tab your way through the code the client asks you to write. It's Friday, 8 p.m. You completely lost track of time. You just got into the zone. You were designing with types and, time just went by. It's super late. Friends called you. You have a ton of unanswered calls on your phone. But you just realized one thing. It's way less likely that this evening somebody will page you because your code is exploding on production. Since you have such a bulletproof design, it is almost unlikely it's going to happen. So tonight, when you will go back home, you will not drink one, but actually 3 beers. So go home and celebrate. Thank you very much.